following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Naming binary molecular compounds. A binary molecular compound consists of molecules containing atoms of only two elements, and we had stated that generally occurs between the two elements are going to generally be non-metals, right? Furthermore, when naming binary molecular compounds, it is done so by assuming that one element is going to be more cation-like, while the other element is going to be more anion-like. And we could determine which element is, we can generally determine which element is going to be more cation-like and which element is going to be more anion-like from their relative positions on the periodic table. Let me explain here. Looking here at figure 1.5, the element that is more towards the right on the periodic table and higher up a group is more anion-like, whereas the element that is more to the left and down a group is more cation-like. Now, moving on, let's take a look at the nomenclature guide here for binary molecular compounds. And naming the binary molecular compounds is also fairly simple. As we see here, it's just going to be two steps. Step 1, name the first element, cation-like element in the formula. Step 2, name the second element, anion-like element in the formula, and change its ending to IDE. Nothing that we haven't already been exposed to in this lecture. Now, let's take a look at a few examples here. We have three compounds, and in naming them, this is just going to be the fluorine. We're just going to need to change that to an IDE ending, so that would become hydrogen fluoride, hydrogen chloride, hydrogen iodide. Let's take a look and see if we are correct. Okay, now what we need to do next, actually before we move on, let's do just a quick little recap here. How do we know that the hydrogen here, right, relative to the other atoms present here, that hydrogen is more cation-like? It's because the hydrogen is going to be more to the left in the periodic table as such. Now, actually, one other thing that we should also take note of here is that when naming binary molecular compounds, they're not always going to be in a 1-to-1 ratio, as we see here. And actually, they're going to be found in various proportions. And to really specify the number of atoms within the binary molecular compound, we use numerical Greek prefixes. Let's take a look at that now on the next slide. Looking here at, as we had just stated on the previous slide, Greek prefixes are used to denote the number of atoms of each element present. And the Greek prefixes can be seen in table 1.7 here, right? It's just going to be mono, di, tri, tetra, penta, hexa, hepta, and so on. Furthermore, the prefix mono is not used for the first element. And lastly, typically when the prefix ends in an A or an O, right? So any of these prefixes, when they end in an A or an O, and anion begins with a vowel, so the anions here, as we see here, right? If they begin with a vowel, the A or O in the prefix is going to be eliminated. So the A or O in the prefix, the A or the O is going to be eliminated. Let's take a look at a few examples. Let's actually work through a few now. Looking here at table 1.6, we have carbon, we have oxygen in the compound, and for a carbon, right, as it says here, the prefix, we only have one carbon, but the prefix mono is not used for the first element. And if we recall, we just named the first element, which is carbon, and then we have to add the IDE ending for the anion, which is going to be carbon, and then this is going to be oxide. However, we do need to demonstrate that there's only one oxygen, thus we need to add the Greek prefix, which is just going to be mono. So the name here is going to be carbon monoxide. If we go ahead and take a look, great. Next, since we have two oxygens present here, this should be carbon dioxide, and since there's three oxygens present here, this should be sulfur trioxide. Let's go ahead and take a look at that next. Sulfur trioxide. Now, the sulfur and the oxygen are actually in one group on the periodic table. Let's take a look at that for just a moment. If we see here, we see that sulfur and oxygen are within one group on the periodic table. However, oxygen is higher on the periodic table, right? Its position in the group here. Therefore, oxygen is going to be more anion-like, as we had just stated a few moments ago. Higher up, the more anion-like it is. Further down, it's going to be more cation-like, and sulfur is more cation-like. Thus, the cation-like element is named first, right? That is why, coming back here, that is why it's named. Sulfur is placed first. Sulfur trioxide. Next, we have 4 fluorines. That's going to be tetra, so it should be sulfur tetrafluoride, as we see here. Now, for our last example here, we have 2 nitrogens present, right? Now, it's going to give it a prefix of di, and we have 5 oxygens present, that's penta. This should be dinitrogen pentoxide. If we go ahead and we take a look, now notice here that let's go ahead and read the third bullet here again. Typically, when prefix ends in an A or O and the anion begins with a vowel, the A or O in the prefix is eliminated. So we see here our anion begins with an O and the prefix begins with an A. So the A is eliminated, and the reason this occurs is to avoid having 2 vowels beside one another. Thus, the name is going to become dinitrogen pentoxide. Okay, great. Let's move on now to our next slide. Looking here, example naming binary molecular compounds. Provide the systematic name for the following compounds. Table 1.8. By this point, you should be fairly comfortable answering this question, so I'll give you a moment, or I'll encourage you to answer this independently. Pause the video now and complete table 1.8. Otherwise, I'm going to go ahead and I'm going to unveil the answers for this table. I'll give you a moment now to pause the video. Okay. Now, looking at we have the following answers for compound 1. It's just going to be nitrogen trifluoride, dinitrogen tetroxide, tetraphosphorus heptoxide, and tetraphosphorus decasulfide. Now, if you're ever unsure, it's always a good idea to check to see that your prefixes, right, are consistent with the subscripts in your molecular formula. Furthermore, notice that the A, right? Notice that the A is dropped from the tetra, and the A is also dropped from the hepta, right? It's from right here, and that's whenever you have the word oxide, just be cognizant of the prefix that goes before oxide. Predominantly, the vowel gets dropped as such. Great, let's now shift our attention towards polyatomic ions.